Hi, I'm Anne, and today we will be talking about Newton's three laws of motion. Let's start with Newton's first law of motion, which states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion at a constant speed and direction until that object is acted upon by an outside force. This is also called the law of inertia. Let's look at some examples. In this example, the water demonstrates inertia as it continues over the rim of the glass after the glass is stopped. This is because the water wanted to stay in motion, but gravity soon took over and the water dropped to the counter. This next example shows how the tray demonstrates inertia as it stays in place even as the tissue paper is removed from underneath it. This is because the paper was not able to overcome the tray's inertia, so the tray stayed at rest. Next is Newton's second law of motion, which gives the equation force equals mass times acceleration. This shows that force and acceleration are directly proportional, meaning that as the net force on an object increases, the object's acceleration increases with it. Conversely, the formula can be rewritten to show that mass and acceleration are inversely proportional. In other words, as an object's mass increases, its acceleration decreases. Here are some examples. In this first one, I exert a force on the chair and make it accelerate across the floor. However, when I exert the same force on the heavier trunk, the trunk's acceleration is much slower. In the next example, I can pick up my smaller dog Stilton and accelerate upwards quite quickly, but when I try to lift my larger dog Kona, who has a greater mass, I accelerate upwards much more slowly. Now let's examine Newton's third law of motion, which states that for every force applied by one object to another, the other object will exert an equal force in the opposite direction on the first object. Now let's see some examples. In this one, you can see that as the ball hits the wall it is thrown at, it exerts a force on the wall, which exerts the same force back on the ball and sends it back toward its thrower. Here we see Stilton being ridiculously silly and crashing right into Kona. If you look closely, you can see that as Stilton exerts a force on Kona that makes her tumble, Kona exerts the same force back on Stilton and makes him tumble as well. Of course, since Kona has a greater mass than Stilton, the force doesn't affect her quite as badly, and she manages to keep on her paws while Stilton is sent crashing to the ground. This concludes our summary of Newton's laws of motion. I hope you enjoyed the video.